Welcome everyone. The question is two resistors with resistances 5 ohm and 10 ohm respectively are to be connected to a battery of EMF 6 volt. How will you connect the resistors to obtain the maximum current? Okay. Calculate the current through each of the resistors. So here obviously if you want to obtain the maximum current, then the resistance should be minimized or the equivalent resistance should be minimized. This 5 ohm and 10 ohm which should be connected, and then these two resistances should be connected in parallel such that the parallel combination of the two resistances should be withdraw maximum current from the 6 volt battery. So let us do this. So this is the 5 ohm. Let us say this is R1 and this R1 is equal to 5 ohm, and another resistor that is the 10 ohm, we can say that is my R2, and R2 is equal to 10 ohm. Now these two resistors are connected in parallel. This parallel combination is connected to the EMF 6 volt. Okay, so this is the EMF and this EMF is equal to 6 volt. And why we have chosen these two things in parallel, we have discussed already. Because if I just take the values, and if I say two resistors are connected in series combination, because two possibilities are there, series and parallel. So if it is R is the series combination, then R1 plus R2 will gives you 5 ohm plus 10 ohm is equal to 15 ohm. But if you connect these two in parallel, then we can say RP, and RP will give you R1 multiplied by R2 divided by R1 plus of R2. So R1 into R2 is 5 multiplied by 10 divided by 5 plus of 10. So this will become 50. This will become 50 divided by 15. So this will become 10 divided by 3. So 3.33 something ohm, or 10 by 3 ohm is also acceptable. So since if you connect these two in parallel combination, since the equivalent resistance is less, so it will draw the maximum current. Okay, so now I replace these two resistances by a single one resistor, and it is also explained that why I have connected these two in parallel. So this is, let us say, 10 by 3 ohm. Okay, 10 by 3 ohm, and this is the 6 volt. Okay, this is the 6 volt. Now what is the main current? That is I in this circuit, and what is the main current here? I in this circuit. So if you want to find it out what is I, then I is equal to 6 volt divided by 10 divided by 3 ohm. So this will become 6 multiplied by 3 divided by 10 ampere. So this will become simply 1.8 ampere. So 1.8 ampere is the current. 1.8 ampere is the current which is just passes through 1.8 ampere. Now obviously when it approaches here, this capital I divided into 2. Through R1 the current is I1 say, through R2 the current is I2 say. But the potential drop across both of the resistors is equal to that of the EMF of the cell as they are connected in parallel. So we can say what is I1? I1 can be obtained by simply dividing E by R1. What is the value of E? E is 6. What is the value of R1? 5. So we can say simply 6 volt by 5 ohm gives you the ampere. So 12 divided by 10, that is 1.2. So rest of the current should be, that is the current through the R2 resistor, that is a 10 ohm, should be 0.6 ampere. So I3 equal to E divided by R2, not I3, it is I2. So E divided by R2. So what is E? E is 6. What is R2? R2 is 10. So very simply it becomes 0.6 ampere. So we can say from here, from the positive of the power supply, 1.8 ampere comes out, and after that it divides into 1.2 ampere and 0.6 ampere, and then these two again joins and forms again 1.8 ampere, and these we can draw the maximum current. Just think, if these two resistances are connected in series, then what will happen? If I try to find it out, then that will be E divided by RS. Okay, what is E? E is 6, RS, so just see, it is 6 by 15 ampere. Okay, so 6 by 15 ampere, so it is a much less current. If you connect the two resistances in series, it will draw much less current from the EMF cell. So if you want the more current from the cell, you have to connect the resistances in parallel. Thank you all of you.